I carry out my job in a number of different settings. First thing is we look at really large samples that we collect from the field, which look like this, and this gives us a broad overview of what the sample looks like, its constituents, and how it may have undergone deformation. The next thing we do is to cut up these large blocks into thin sections, and we use these thin sections to essentially get a window into the history of the rock, how it has been deformed over time, what sort of deformation imprints it still preserves. And then what I do, my technical competence is studying the deformation behavior of rocks using electron backscatter diffraction. So this is what a typical electron backscatter diffraction map would look like. My studies essentially involve investigations into the history of deformation of rocks across a range of scales. The most fascinating and interesting aspect of the work that I'm associated with as part of the Deep Sea project is the risk factor associated with the accelerated transition towards greener energy sources like green hydrogen produced from naturally occurring rocks. So for example, if we are converting large volumes of one type of rock to a different type of rock and producing hydrogen from it, there is the potential that these processes induce a very large risk in the form of earthquakes. And so I think that while there is a need for study on how we can accelerate our transition towards greener energy sources, we must also be aware that an accelerated transition might induce certain risks which might be catastrophic. So for me, that is the most fascinating aspect of my study.